Welcome to Module 5 of this data science course, where we'll be looking into careers in data science under the following units: career path in data science, required skills and learning roadmaps, and next steps for aspiring data scientists. Career path in data science. The field of data science offers a wide array of career opportunities across virtually every industry, driven by the increasing importance of data and decision making. While job titles and specific responsibility can vary between organizations, several core roles commonly form the backbone of data science teams. Understanding these roles can help aspiring professionals identify a path that aligns with their skills and interests. Here are a brief description of three prominent career paths. Number one, data analyst. Data analysts primarily focused on collecting, cleaning, analyzing, and interpreting data to extract actionable insight that supports business decisions. They often spend significant time querying databases, manipulating data in spreadsheets or programming environments, and creating reports and visualization to communicate findings to stakeholders. Oops. Common tools include SQL for database query, Excel and Google Sheets for data manipulation and analysis, business intelligence platform like Tableau or Power BI for visualization, and often scripting languages like Python or R for more advanced analysis. Positioning. This role is often considered an excellent entry point into the data field, providing foundational experience in data handling and analysis. Career progression can lead to senior analyst roles, analytics management, or transitioning into data science. Data scientists. Data scientists typically tackle more complex problems involving predictive modeling and machine learning. They design experiments, develop statistical models and machine learning algorithms, analyze large and often unstructured data sets, and communicate complex findings. Their work involves a deeper application of statistical theory and computational techniques compared to data analysts. Tools. Proficiency in programming languages like Python or R is essential, along with libraries for data manipulations, Pandas, NumPy, machine learning, scikit-learn, TensorFlow, PyTorch, and statistics. Strong statistical knowledge and machine learning expertise are required. Positioning. This role often requires more experience than an analyst position, and advanced degrees, master's or PhD, are common, though not always mandatory. Career path can lead to senior principal or scientist roles. Specialization in areas like artificial intelligence or leadership positions such as chief data officer and data engineer. Data engineers are responsible for designing, building, and maintaining the infrastructure and systems that allows for efficient and reliable data collection, storage, processing, and access. They build data pipelines, ETL, ELT processes, manage database and data warehouses, and ensure data is readily available and usable for analysts and scientists. Tools. Key skills include strong programming, often Python, Java, or Scala. Expertise in SQL and various database technologies, both rational like PostgreSQL, MySQL, NoSQL, like MongoDB. Big data frameworks such as Spark and Hadoop. Data warehousing solutions such as Redshift, BigQuery, Snowflake, and cloud platforms such as AWS, Azure, GCP. Positioning. This role requires strong software engineering and system skills. Career progression can involve moving to senior engineer, data architect, or cloud data engineering roles, specializing in areas like big data or real-time processing. Required skills and learning roadmaps. Success in any data science career path requires a blend of technical proficiency and essential soft skills, while the emphasis might shift depending on the specific role. For example, deeper machine learning for scientists, stronger infrastructural skills for engineers. A common foundation exists. Essential technical skill, programming language. Proficiency in at least one programming language commonly used for data analysis is crucial. Python is widely popular due to its extensive libraries for data manipulations, analysis, visualization, and machine learning. R is another strong contender, particularly favored in statistics and academia. SQL, structured query language, is often fundamental for interacting with relational databases, a common task processing data. Statistics and probability, a solid understanding of statistical concepts. For example, distributions, hypothesis, testing, regression, and probability theory is necessary for analyzing data correctly, building reliable models, and interpreting results. Machine learning. For roles beyond entry level analysis, familiarity with core machine learning concepts such as supervised and unsupervised learning and common algorithms is essential. This includes knowing how to train, evaluate, and potentially deploy models using library like scikit-learn, TensorFlow, or PyTorch. Data wrangling and preprocessing. The ability to clean, transform, and organize raw messy data into a usable format is critical. Everyday skill for working with data. Libraries like Pandas and Python are key tool here. Data visualization. Creating clear and effective visualization, such as charting graphs, is vital for exploring data and communicating findings to others. Familiarity with libraries such as Matplotlib and Seaborn in Python or tools like Tableau or Power BI is important. Databases and big data technologies, depending on role. Understanding different databases types, such as SQL or NoSQL, is often required. For roles dealing with very large data sets, knowledge of big data tools like Apache Spark, Hadoop, and cloud platforms such as AWS, Azure, and GCP is increasingly valuable. Essential soft skills. Communication. This is paramount. Data professionals must be able to clearly explain complex technical concepts and findings to diverse audiences, including non-technical stakeholders and decision makers. Effective data storytelling. Crafting compelling narrative around data insight is a highly valued skill. Problem solving. At its heart, data science is about solving problems. This requires strong analytical thinking, the ability to break down complex issues into manageable parts, and identifying appropriate methods and resources to find solutions. Critical thinking. Data scientists need to objectively evaluate questions, data sources, assumptions, methodologies, and results. They must avoid biases and challenge findings rigorously. Intellectual curiosity, a genuine desire to explore data, ask why, dig deeper than the surface level answer, and continuously learn is a hallmark of a successful data professional. Business acumen, understanding the context of the business or domain in which the data exists is crucial for asking relevant questions, interpreting results meaningfully, and ensuring that the data work drives actual value. Teamwork and collaboration. Data science is often a team sport. The ability to work effectively with colleagues, such as analysts, engineers, domain experts, product managers. Share knowledge, give and receive feedback, and contribute to common goals is essential. Follow a learning roadmap. Start with foundational concepts. A typical path involves learning a programming language such as Python, is highly recommended for beginners, followed by essential libraries, such as NumPy and Pandas, SQL for databases, and fundamental statistics and probability. Subsequently, delve into data visualization and exploratory data analysis before moving on to machine learning concepts and algorithms. Utilize learning resources. Leverage the wealth of available resources, online courses, platforms such as Coursera, DataCamp, EDX, and Simple offer structured learning path and certifications. Supplement these with tutorials, official documentation for tools like Pandas and Scikit-learn, books, and engaging with online data science communities. Prioritize and on practice. Theoretical knowledge alone is insufficient. Actively apply learned concepts by working in projects. Start with guided projects, then tackle independent ones. Utilize publicly available datasets from sources like Google Datasets, Search, or government portal, such as data.gov. Analyzing personal data can also be a motivating way to practice. Build a portfolio. Document your project and showcase your skill. Create a portfolio that includes code. For example, hosted on GitHub. Explanations of your process, visualizations, and key findings. These serve as a tangible evidence of your abilities for potential employers. Platform like GitHub, Kaggle, or even a personal blog can host your portfolio. Network and engage. Connect with other data science professionals and learners. Participate in online forums. Attend virtual or local meetups and conferences. And engage in discussions on platforms like LinkedIn. Networking can lead to learning opportunities, mentorship, and job prospects. Embrace continuous learning. Data science is a rapidly evolving field. New tools, techniques, and algorithms emerge consistently. Cultivate a habit of a lifelong learning by following industry blog, reading research papers as you advance, taking refresher courses, and staying curious about new developments. Also, stay informed about ethical consideration and best practices in AI and data handling. The path to becoming a data scientist requires dedication and persistence, focusing on building a strong foundation, consistently applying skills through practical projects, and actively engaging with the field are a crucial step towards building a successful, rewarding career. Below are recommended resources for Module 5. They include career guide, skills list, roadmaps, and portfolio platforms. In conclusion, diverse career paths exist, notably data analyst, data scientist, and data engineer, each with distinct focus and skill requirements. Success requires a combination of technical skills, such as programming, statistics, machine learning, and visualization, are crucial soft skills such as communication, problem solving, and curiosity. We've come to the end of this data science course training where we looked at careers in data science. Under the following unit, career path in data science, required skills and roadmaps, and steps for aspiring data scientists. This course has also provided a foundational glimpse into the world of data science. The data field is vast and constantly evolving, offering exciting challenges and opportunities. The journey to becoming proficient requires dedication, but the skills learned are highly valuable and applicable across many domains. Be encouraged to continue exploring the topics that captured your interest during this overview. Remember that consistent practice, applying concepts to real data sets, and engaging with the vibrant data science community are keys to growth. Maintain your curiosity, embrace the learning process.
Thanks for watching. If you found this video helpful and you're passionate about learning, don't forget to hit that subscribe button. We share practical tips, deep dives, and step-by-step guides to help you grow your knowledge and skills. You can also visit our website through the link below to access engaging courses. So if you're ready to keep learning and stay ahead, subscribe now and turn on the bell so you never miss a new video. See you in the next one.